All right, guys. Just make a couple videos today. Just working on using these derivative rules. Okay, so you might want to keep this guy handy. We'll refer to it. Okay, so let's see this first one. Okay, I've got f of x equals negative 5x cubed plus 10x squared minus x plus 26. Okay, so this guy is real straightforward. Whether you want to, call your derivative f prime of x, okay, or if you want to say, df dx, it doesn't make any difference. We use all that notation, okay, freely. Okay, so all we have to do is just apply the power rule to all four of these. Okay, so the 3 goes out front, so I'm going to have negative 5 times 3x and then subtract 1 from the 3 squared, plus I've got that 10 out front. I move the 2 out front, so 2x and then 2 minus 1 is 1. Okay, minus, this is x to the first, so when I move the 1 out front, it becomes x to the 0th, which is just 1, so I just get the coefficient, minus 1, and then anytime we take the derivative of a constant, we get 0. And then we just simplify. So I'm going to get negative 15x squared plus 20x minus 1. We've got our first one done. Okay, so let's see this second one right here. Okay. All right, so I have f of x equals 15 over x to the 4th plus the 5th root of x cubed minus 9 over the cubed root of x squared plus 3 radical x over 10. Okay, so the first thing I want to do is get rid of root form. I want everything in exponential form. And then if I happen to have a variable in the denominator, I want to get it out of the denominator using a negative exponent so I can apply the power rule. Okay, so this guy right here becomes 15x to the negative 4th. All right, this guy right here becomes x to the 3/5. This guy, not only is it going to be x to the 2/3, but it's down below, so I bring it up above, becomes negative, so I get 9x to the negative 2/3 plus 3/10 x to the 1/2. Okay. Now I apply the power rule. Okay, so let's see what we got going on here. So this is going to give me, I bring the negative 4 out front, so I get negative 4x, and then I subtract 1, that'd be to the negative 5th, plus, okay, bring the 3/5 out front, so I have 3/5 x, and then we subtract 1, so 3/5 minus 1 would be the same as 3/5 minus 5/5, so I get negative 2/5. Okay. All right, I have this minus 9. I bring the negative 2/3 out front, negative 2/3 x, and then I have to subtract 1. So negative 2/3 minus 1 would be negative 2/3 minus 3/3, so I get a negative 5/3. Okay, plus I have the 3/10. Bring the 1/2 out front, so 1/2 x, and then I subtract 1, so that'd be negative 1/2. Okay, now it's just a matter of getting it into a form that we like. So the first thing I always do is get rid of the negative exponents. Okay, so let's see. Okay, this would be negative 60 times 1 over x to the 5th. Okay. This guy is 3/5 times 1 over x to the 2/5. Obviously, this guy is positive now. Okay, so let's see. 3, 3, okay, that's going to be a positive 6 times 1 over x to the 5/3, okay, plus this would be 3/20 times 1 over x to the 1/2, okay. All right, so let's see. I'm going to get negative 60 over x to the 5th, okay, plus 3 over 5x to the 2/5 plus 6 over x to the 5/3 plus 3 over 10x to the 1/2, right? Okay, so this right here, you could say, well, okay, that is in, exponential form right there. But what if we want to get it out of exponential form and put it back into root form? Okay, so you don't have to do anything here because obviously that's not a root, but this is a root, that's a root, that's a root. Okay, so let's see. I would just bring this guy along for the ride. All right, let's see. This guy would be 3 over 5 times the 5th root of x squared. Okay, this guy would be 6 over the cubed root of x to the 5th. And this guy would be 3 over 10 times the square root of x. And then I'd say this is the only guy we got to worry about because that guy's not in simplest radical form, okay? All right, so if I put that guy in simplest radical form, okay, I'm done with this first term. This is already in simplest radical form, so we leave that guy alone, times the 5th root of x squared. And then let's see, this guy. Okay, well, x to the 5th would be x cubed times x squared, so the cubed root of x cubed is x, and I'm left with the cubed root of x squared underneath, and then plus 3 over 10 times the square root of x. Okay, so this would be our root form right here. All right, now you could go and rationalize, okay? I don't know if I necessarily need to, okay, but I will just to take a look at it. Okay, so negative 60 over x to the 5th. See, this guy, I would have to multiply above and below by, what is it? I would need the 5th root of x cubed above and below. So that would be 3 times the 5th root of x cubed all over 5x. Let's see, this guy I would have to multiply by the cubed root of x. Okay, so I'm going to get 6 times the cubed root of x all over, that would be x times x, or x squared. And here I got to multiply by the square root of x. Okay, so I'm going to get 3 times the square root of x all over 10x. Okay, so this guy right here is just rationalized. Okay, still root form. Okay, so we have a couple different possibilities. It's just a matter of what we're looking for. We've got exponential form. Okay, we've got root form right here. Okay, and then if you rationalize root form, we have this. Okay, and once again, which answer is the best? It depends on who's standing at the front of the classroom. Okay, for the time being, I'd say that all three of them are good, unless, of course, I ask you to leave your answer in a very specific form.